Hi, my name is Shrivant Reddy, and this is my lab on the motion of falling object. For our introduction, we are looking at how an object interacts with gravity over a certain amount of time and distance. Um, in this case, we're splitting this into two parts. We have one with just gravity in consideration, and then the second part with both gravity and drag put into consideration, and the forces acting on our object, which in case is a paper ball. We used computational models from GlowScript as well as Tracker in order to collect both experimental and real-time data. And we were comparing these two together in order to determine the differences between the two. We used a yardstick for our scaling in our real-time video, and we were able to determine that the lab using gravity and drag force is more accurate than just gravity. The physics principles behind our lab was Newton's second law, the momentum principle, and we saw that the force acting on an object in this case is F equals ma, or mass times acceleration, or gravity, and the change in momentum over the change in time. Our drag force equation was negative b. B in this case is a drag force coefficient or constant, v squared times the directional vector. We were able to determine that gravity was always going towards the center of the Earth, and our drag force was always going to act in the opposite motion of our ball. So if our ball was tracking to the left, drag force would be going the opposite direction to the right, acting against the the motion of the ball. The data that we collected using Tracker is reflected here with the mass over time, or over a distance over a certain amount of time, and our y over a certain amount of time. Using our computation model, this is what we got without drag. So this ball is being represented in our glow script without drag. And this is data we collected with the ball without drag. And this is a ball with drag. And the data we collected for the ball with drag and glow script. The results we found was that the model with drag and gravity was more accurate than just model with gravity. And we were also calculated for human error, and adding velocity to the falling object may have affected the closeness to the ball. So, but all three relatively had the same slope and shape of curve, which reflects the predominant force, which is gravity acting upon the ball in the end. What does this mean? This means that terminal velocity is the max velocity an object can reach when falling through the air. Because drag is a force that resists motion, it can overcome the force of gravity. Eventually, the net force becomes zero, and the object reaches a constant maximum velocity. This behavior is represented through our computational models with drag, where we made drag never to exceed the force of gravity. On the other hand, in the model without drag, the object's velocity would keep increasing if done over a long enough time. What if? Imagine if our object was initially thrown straight up with the same initial speed in our experiment. Would the object take what would the time be for the object to reach the ground? Would it be the same, longer, or shorter than the time it took in our original experiment? Also, would it take longer than the time in our original experiment because the initial speed of the y direction would be higher, take longer to gravity to make velocity negative direction hit the ground? Or, for example, an object with an initial velocity of 0 to 10 meters will hit the ground in 1.43 seconds, but an object going 3.3 million meters per second upwards will take 1.7 seconds. All right. Thank you. That's my lab.